This section is on probability spaces. So the point of probability is that we can't always predict things with absolute certainty. So we can make an estimate on how likely it is for something to happen. So our official definition here for probability is a measurement of how likely things are to happen. Generally, probability is a ratio or a fraction of the favorable outcome out of the total number of outcomes. So, for example, rolling a 6 on a die. Favorable, well, there's only one side of the die that has 6 dots on it, but the total number of outcomes are 6 because it's a 6-sided die. So our total probability there would just be 1 out of 6, or 1/6. In this example, we've got 20 marbles in a bag, 4 are blue, 11 are red, and 5 are green. What is the probability that a blue marble gets picked? Well, there are 4 blue marbles in the bag, so the favorable outcome is, would be 4. And then the total number of outcomes is 20, since there's 20 marbles in the bag. So this one's pretty straightforward. We can just write that the probability is 4 out of 20. And most of the time it's nice to see this simplified, so that would be the same as 1 out of 5. Or you could write it as a percentage, so 20% or 0.2. So a lot of different ways you may see an answer pop up, but these are all the same. A couple vocab terms here. An event is any subset of the sample space. So let's say the event I want to happen is rolling a 5 from a pair of dice. That could happen here from 1 and 4, at least from these that are listed out in this sample space. And right here, a 4 and a 1. Now, a simple event is an event that consists of just one outcome. So say maybe specifically we wanted a 4 first and then a 1. Well, then the simple event would be here, where we roll the 4 first and we get the 1 second. An impossible event, this is a special case of an empty set, and that's how we illustrate an impossible event. We just draw brackets and leave nothing in there to show that the event we want to happen, or that is being asked to happen, cannot occur. So in this case, an example of an impossible event with 2 dice would be rolling a 13, since the most we can roll is a 12. Now let's look at the example where we toss a coin 3 times and record the results. And note here that the order does matter, so there's a difference in heads, heads, tails, and heads, tails, heads, and so on. So let's look at this first event. Toss 2 coins, toss 2 or more heads. So we can have heads, heads, tails. Okay, that's 2 heads. Heads, tails, heads, tails, heads, heads, and heads, heads, heads. Those all fit into that criteria. So those are 4 of those events within the sample space. Toss more than 2 heads. The only time that can happen is if we get all heads. And that's a simple event because it's just one of the events by itself. Toss 2 heads or fewer. So we could have all tails. Just 1 head, just 1 head, just 1 head, 2 heads, 2 heads, 2 heads. So all 7 events except for getting all heads, basically. So first toss is heads. So heads, 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 tails, heads, tails, heads, heads, tails, tails. So 4 out of that 8. Toss the same number of heads as tails. Well, since there's an odd number of flips here, that's going to be impossible. It's either going to be 2 and 1, or 1 and 2, 0 and 3, or 3 and 0. There can be no tie. And the last one, toss 3 heads or fewer. This is a very vague description, so we could have all heads, notice back up top, or fewer than 3 heads, which pretty much refers to all the other possibilities. So we could just say that that event includes the entire sample space. And we could say the probability of that would be 1 or 100%. Last two vocab terms of this section. Probability assignment is a function that assigns to each event E a number between 0 and 1, which represents the probability of the event E, and which we denote PR and then E. And that's between 0 and 1 because 0 would mean 0% chance, and then 1 would represent 100% chance, so anywhere in between. So like 0.5 would be like 50%, or 0.75 would be 75% chance. And the probability space, this is just once we have our assignments made, this is the combination of the sample space and the probability assignment. Now we can work with probability assignments pretty easily. Let's say we toss a coin 2 times and record the results. We've worked with this example plenty of times already. So heads, 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 tails, tails, heads, and tails, tails. So sample space of size n equals 4. And in this case, each event has an equal chance of happening. So for example, the probability of assignment for heads, heads, we'd write it as PR, and then in the parentheses write the event itself, and then give the probability. So, and a lot of the time you'll see probability given as a decimal instead of a percentage. So 0.25, which is the same as 25% or 1/4. And it's important to note that probability assignments for all the events should always add up to 1. So kind of like 25%, 25%, 25%, 25%, should always add up to 100%. That addition concept applies the same here. So say we've got a basketball player trying to make some free throws. The sample space is either failure or success. And maybe based on statistics or just history of shooting, the chances or the probability of missing the shot is 0.2, so 20%, and the probability of making the shot is 0.8 or 80%. So again, these should always add up to 1.